All right, this is our second video introducing factoring. So this is one where we're actually going to learn how to factor using what is called the box and diamond method. Okay, now to start off though, we're actually going to correct the practice problem from the previous video. I'll look at it, of course, in Canvas as well, but we need something to look at, so we're going to just use that one. So I gave you the rectangle 10x squared, negative 35x, 14, and negative 4x, and I asked you to find the outside dimensions. So when you did that, hopefully you said, 10 and negative 4, well, that could be a 2. If that's a 2 with a 10, that should be a 5. Both of those need to be an x. If this is a 5, that could be a negative 7. And if that's a negative 7, then this would have to be a negative 2. And then you check it, 2x times negative 2 does give me negative 4x. So that's good. So then you would write it out as 2x minus 7 times 5x minus 2 equals 10x squared minus 39x plus 14. Okay? Check your work right now. Make sure that's what you got when you did the practice problem. Now, we have a new pattern to look at today. And this is that if you take the diagonals, use different color. If you take the diagonals of one of these generic rectangles, so we're not using the outside pieces, we're just using these inside pieces, and we multiply them together, there is a pattern. So let's try it. I want you to multiply 10x squared times 14, and I want you to multiply negative 35x times negative 4x. And I want you to write what you get, just like here. Try it now. Did you get 140x squared for both? Because 10x squared times 14 equals 140x squared. And negative 35 times 2 would be negative 70. Times another 2 would be negative 40. Make it a negative, so it's a positive. Times negative 4x would also give me 2 x's there, so that's how we get my x squared that way, 140 x squared. Now, this pattern always works. So if you look at the notes from what we did in the last video, I want you to try it on those 2 examples we did. Test it out. What do you get when you multiply the diagonals with each other? Do it now. In the first one, you should have got 30x squared for both. And on the second one, it should be negative 144x squared for both. Okay, so we're going to use that fact. Keep that in your brain for later. And of course, I haven't told you why this is true. It's relatively easy to prove. If you're interested, you don't have to, but if you're interested, try taking a generic rectangle and just label it AX, B, CX, D, something like that, just like all variables, and like multiply in, and then do the diagonals and see what happens. This is like a little extension piece. Okay, if you're curious to know why this pattern always works, then just like try it with all variables and no numbers, and you can prove that it works. Okay, so now let's try to factor. We're going to put all the pieces together. This equation right here. So remember, factoring means that I want to work backwards to figure out something times something equals this. Okay? Now, what do I know about this expression here? I know that if I put it into a generic rectangle, we're going to do this. This is our first step. if I put it into a generic rectangle, I know that whatever is in here, these things are going to have to simplify to be that, right? Because that's what we do up here. We take these numbers that are on the inside and we simplify them to get this piece. Now, the one that's the x squared term, that always stays the same. And the one that's just the like c term, the one that doesn't have an x, that always stays the same. So that means that I can put those ones in, but they have to be at like a diagonal from each other, right? So I can do, in this one, I would have 2x squared and 3, or I could put them like on the other diagonal. Take a minute, make sure you understand what I did there, because that's a really important piece. Why did I put the 2x? How do I know the 2x squared can go there, and how do I know that the 3 can go there? I'm sort of like working backwards from my simplifying. I'm taking the equation, and I'm trying to fit it back into a generic rectangle. Now, the tricky part is, what about that 5x? There's 2 boxes here, but only one 5x. Where does it go? Well, what do I know about that 5x? I know that these 2 boxes right here, if I add them up, they're going to have to equal 5x, right? I know that maybe I'll call, just for fun, maybe I'll call this box A and this box B. I know that A plus B has to equal 5x. Make sure you understand why, right? That's what's happening when I simplify. In order to get that negative 39, what did I do? I added together those 2 boxes. That same pattern always works, right? I simplify those by combining them. But what else do I know about that? So like this could be a 2x and a 3x. Could be a 4x and a 1x. Could be a 5x and a 0x. Right? I know it's going to be 2 things that simplify to 5x. What else do I know about this though? Well, what I just learned up here. I know that when I multiply these 2 numbers together, it's going to be the same thing as when I multiply these 2 numbers together, which would give me 6x squared. So I know that A times B, right here, will also give me 6x squared, because it's always the same. So A times B will give me 6x squared. So I know that. I know that these 2 numbers in the box are going to add to 5x, and they are going to multiply to 6x squared. What does this remind you of? Hopefully, this reminds you of a diamond problem. I know that my 2 numbers are going to add to 5x, and I know they are going to multiply to 6x squared. Even if you've already figured out what the 2 numbers are, like, please make sure you're following with me, all right? Because they're not always going to be this easy. So that means that now I just have a diamond problem I need to solve. What are 2 numbers that multiply to 6x squared but add to 5x? Well, 2x and 3x. So then I go back to my generic rectangle. Maybe this time I'll write it separately. Normally you wouldn't need to write it again, but just for the sake of notes, I'm going to write it again. So we've got 2x squared and 3. And now which one goes in which spot? It doesn't matter, right? Just like how it didn't matter where I put these ones, as long as they were diagonal from each other, it doesn't matter where I put these, as long as they're diagonal. So I'm going to do 2x and 3x. And now I just need to find the outside dimensions and write it as the factors. So this gives me 2x. That must just be an x. This must be a 3. And that must be a 1. So that gives me x plus 1 times 2x plus 3. And I think that that equals, let's check it, 2x squared plus 5x plus 3. which is what I wanted to have in the beginning. So I just factored this expression to get this. It's a lot. Okay, we're going to do another one, and then you'll have your practice problem. So you're going to try it. 2x squared plus 7x plus 6. Follow your notes. Rewatch the previous stuff if you need to. See if you can get all the way through. And then I'm going to go through it much quicker this time. Okay? Pause and try this one, please. We start by setting up our rectangle, and we put in the ax squared and the c value. So that gives me 2x squared plus 6 there. Then I need to set up a diamond. In my diamond, I know that these two numbers right here are going to add to 7x, and they're going to multiply to 12x squared. Now I solve my diamond. So what are two numbers that multiply to 12x squared and add to 7x? 3x and 4x are. So then I can put those back in my generic rectangle. 3x and 4x. It doesn't matter which one goes where as long as they're diagonal from each other. And then I find the outsides of my rectangle. So this must be a 2x, which means this must be just an x. This is an x, this must be a 3, and this must be a 2, which means that my factored form is 2x plus 3 times x plus 2. I can check my work by making sure that that works. 2x squared plus 7x plus 6. All right. Your practice problem. You are going to factor 6x squared plus 17x plus 12. What you are going to type into Canvas is going to be the factored form of this. In other words, this part right there. Okay? Give it a shot. We'll be practicing this so much next week. You're going to be amazing at it by the time we're done. Good luck.